So my name's Jim. I help organise tonight. I just wanted to say a few words quickly about our sponsors and that sort of thing. Just firstly though, who hasn't been to an alt.net before? Many? Alright, so there's a few. If you don't know what alt.net is, it's you maybe think of it like an open source .net or something like that. So we are a .net user group, but we spend a lot of time also looking at other languages or platforms or different ways of doing things. It's sort of born around that whole TDD time and all that sort of stuff, and sort of that sort of focus. So Keandra IT are our main sponsor tonight. They provide the venue and the pizza. So this is Keandra here. We're a sort of custom software place, so I work for these guys. And our other sponsor is DDD, Developer Conference in Melbourne, and they provide the beer. So does everyone know about DDD? Anyone not? Yeah, a couple. So DDD is a community-run conference. So at the moment we're actually in call for content. It's about $25 and it runs mid-July at Swinburne University. So anyone can submit a topic for the conference, and then the actual attendees will vote for it, and the agenda gets announced and stuff like that. So I'll send out a link to the group. I should have done that already. We announced the link, the date the other day. And finally, I just wanted to talk a little bit about next month. So next month we've got another story about someone building a real system, and it's by this guy called Tim Dwyer, who's out of Monash University. And he's going to come and talk to us about building the code visualization tool that's been in Visual Studio since 2010. So that's the thing that when you do the analyzation, it sort of lays out all the assemblies and classes and does all the dependency tracking and that sort of stuff. So Tim's going to come along and talk to us about that. But right now, I'll hand over to the guys on the night, and I'll let them introduce themselves and what they're going to talk about.
Okay. Well, thanks everyone for coming along. Thanks to Jim and Keandra for having us. My name is Marcus. I work for Visa Global Logistics. We're hogging the night tonight, and we're a group of 4 of the development team will be presenting tonight, and we'll be telling our story of the last few years of our software development and what we've been doing. So I'm Marcus. We've got 4 presenters tonight. We'll spread it out through the night, so don't worry, you won't get sick of the sound of my voice. And our title tonight is From a Big Ball of Mud to a Multi-Domain Distributed System. Now, we kicked around a few alternative titles. We went highbrow. Dorodango is the Japanese art of taking balls of mud and meticulously, painstakingly polishing them until they're an artifact of extreme beauty. We had lowbrow, how to polish a turd. The jury was out on which of those would go, so we went with the big ball of mud to a DDD multi-distributed system. So, who are we? Who is Visa Global Logistics? To start with, we're nothing to do with the credit card company. We always get asked, so don't complain to us about your interest rates. We're an international freight forwarding company. The simplest way to explain a freight forwarding company is we're basically a travel agent for your freight. So if you've got cargo you need to move from one country to another, we're the people that you can come to. We organise shipping containers, we organise air freight, we organise the documentation, the customs clearance, getting containers on trucks, moving things from here to there. So we're a logistics company. It was formed a bit over 30 years ago in Sydney by a couple of Italian guys who I think at the time had no idea what they were doing and became extremely successful. So these days we've got 400 staff globally, in Italy, China, and around the place. And we're hiring, so if you like what you hear tonight, then come and see me afterwards. We're hiring for... Yep. I don't know. Is it? Okay, we're hiring, but we're not screen capturing, so... That's our email addresses. If you want to get in touch with me afterwards, yeah, just come and grab me. So we're a logistics company, but we're here to talk about the software. So we've got a package called OneTrack, which is our online tracking, operations and logistics management system. We've got to talk about the concept of a product versus a project. So what we've got here is very squarely in the camp of a product. This has been in development since 2004. So think about what you were doing in 2004 and ask whether you're still working on the same product that you were working on in 2004. Because I am. Which is good and bad. Really the whole purpose of this talk is to explain that, is to give our approach to how we've dealt with some legacy code. So if you rewind to 2004, it was .NET 1.1 with a SQL 2000 backend. We're really talking cutting edge here. So if you think back to .NET 1.1, no link, no generics, there weren't even nullable value types in .NET 1.1, so it was pretty cutting edge. Most of our business logic was sitting in T-SQL stored procedures. Don't all jump up and down in extreme excitement. We didn't have any automated testing. We probably didn't even know what they were. It was pretty excellent. We had a great time. Where the story that we're going to tell tonight starts is actually 7 years in the future. So we're talking about 2010, 2011. Despite the architectural limitations, the project became quite successful and evolved, and the product grew quite substantially over the ensuing 7 years. It went from a single developer, me, to a team of 5 of us, 4 of whom you'll hear from tonight, and encompassed quite a large proportion of Visa's business operations, and it was effectively a critical system for us. So we'd made some changes. Stored procedures were gone, thank God. We had things in Hibernate. That was done fairly early on in the piece, but we didn't do any raw SQL queries. We're on .NET 4.0, so nullables, generics, link, had some nice language features. We had automated testing in place. I'll discuss this briefly a bit later on in the talk, but that was largely the form of big, heavy integration tests. But we had some testing, better than nothing. It was much better. But working on the software was kind of like that. We're really dealing with how software can sometimes evolve. We were dealing with a big ball of mud. And so tonight's talk is really about what did we do. We had a team of people dealing with a big ball of mud. It was complex. Freight forwarding is quite a complicated business. There's a lot of different business operations that happen. They have lots of different variables. It's a complicated business, and necessarily the software has to deal with a degree of complexity. It was fragile though, so make a change, something breaks, didn't expect it, didn't know, things weren't tested, all of those things that people tell you when they tell you that TDD is a good thing. It was hard to test. To write a small test and test a piece of logic, if you could test it, would require large parts of code to set things up, make sure the database was in the right state, run the code, check a whole bunch of things, hope that everything worked out okay. So it was hard to work with. It was hard to understand, as the people who came on through the course of those 7 years will agree. There was a high barrier to learning exactly what the hell the code was meant to do. In fact, even those of us who'd been there since the start sometimes had difficulty understanding what was meant to happen. So we were stuck with the situation of what the hell are we going to do and where should we start? So we've got a big ball of mud, we've got a working product which is providing value to a business. We need to make changes, but changes are hard and changes are difficult. What do we do? So first thing we took was an approach of saying we can't throw it away and start again. We had a working system, we had to keep it in operation. So we took an approach of selective refactoring, basically saying if we needed to change something, then we'd look at refactoring it. If it wasn't broken and if we didn't need to touch it, we'd leave it alone. So there are still a few bits of code sitting in the repository which I was trawling back through last week, which are pretty much back from 2004. It was a little bit of a shock to see some of those bits of code, but they're still there. Heavily influenced by Eric Evans's domain-driven design book, The Big Blue Book. It's a cracker. If you haven't read it, can't recommend it highly enough. It's a fantastic book. We wanted to try and introduce a domain model. Now, putting a domain model straight into a big ball of mud isn't going to work, but what we wanted to do, and what I'll talk about a bit in my section here, is how we started to introduce what we could call a pseudo domain model. Some of the things the guys will talk about a bit later on will talk about some more some techniques we did to actually get real domain models into our software. Getting dependency injection using structure map, which is a fantastic tool. Using IOC and dependency injection, that was really step one. That was the first thing we had to do to start decoupling things out of the big ball of mud and starting to chisel out bits out of there. So that was a really important first step. So unit testing, again, if we can separate things out, we've got half a chance of unit testing as opposed to big heavy integration tests. We can run small unit tests. So heading towards the path of actually having unit testing, and an in-process event bus. This is something which I'll go into in a little bit of detail shortly, but that was really where we started to see some real benefits in what we were working towards. So we had what we could call charitably an anemic domain model, a term coined by Martin Fowler, I believe. So you get a class such as a container. So this represents a shipping container that you see coming around on boats and zipping around on trucks here and there. So containers have a whole bunch of properties, but let's just take a look at something which is quite important for us to deal with, which is the weight of a container. So this is pretty much what the class was somewhere around 2007, I think. We've got a weight, a tear weight, and a gross weight. So the weight is the weight of the cargo in the container, the tear weight's the weight of the container, and the gross weight is the overall weight. Now the gross weight is extremely important. If you're carrying a container around on a truck on the roads, it's not allowed to be overweight, because if you have an accident, chances of people dying is pretty important. There's some fairly serious legislation around making sure that containers aren't overweight. So there's actually a real business problem to deal with here. There's a number of problems which we have to tackle here. For a start, weight is a completely meaningless term. Tear weight and gross weight's a little better, but weight doesn't really tell us much. We can do something in the middle of a method like this. Can you see that all right at the back there? Sort of. What we're doing there is we're calling container.weight and we're setting it to 10,000. We can just do that in the code. There's a public setter. We can do what the hell we like. What that suddenly means is our gross weight's completely wrong, and we run the risk of reporting incorrect weight to our transport department. Containers being too heavy on the roads, disaster could potentially ensue. So what do? First thing we have to do is invent a new word, and that word is domainify. So one of the things the team's done really well is invent ridiculous words to describe things we do. So if we're going to make something work, we're going to domainify it. So the first thing we'll do is we'll take the setters and make them protected. We now have a set cargo weight method, which can enforce that we recalculate the gross weight. Okay, it's pretty basic, and there's nothing super exciting in there. But it's an important step forward from getting away from an anemic domain model, and it paves the way for some of the more complicated things which we want to do further down the track. So, the thing we want to do most of all is an in-process event bus, which is pretty much our best way to break down a complex domain model and really try to get our claws into that big ball of mud. So, a simple business scenario we might talk would be something like what I described before. We're going to call that set cargo weight method, but let's just say if a container is heavy, we need to notify our transport manager and say, hey, this is a heavy container. You actually have to have different trailers and different setups, and there's places that you're not allowed to drive the container. So the transport manager needs to know about that, a heavy container. So we're going to build a little method called update container weight on some sort of a service class, which will set the cargo weight, and then if the weight's over some threshold, then it's going to use an alert notification service to send an alert to the transport supervisor. All well and good, but it suffers from exactly the same problem as the last thing. That sending of an alert is absolutely critical to the business, but you can still call set cargo weight, and there's nothing that enforces that you're going to call the send alert to transport supervisor method. So the developer has to know, and this is something which is pretty important. All of a sudden you're putting the load of information on the developer to understand that that's what you've got to do. You've got to call set cargo weight. You can't call container.setCargoWeight. It's kind of ridiculous, and it's something where you're expecting particularly a new developer coming on board the team to know that that's what you do, as opposed to the code expressing what the intention of the business is. So we could naively say, well, we're just going to put the alert notification service into the container. And what that does is it creates an artificial external dependency on this arbitrary alert notification service and sticks it in the middle of your business logic where it doesn't really belong. All you end up doing is taking your service classes, which might do all sorts of things, and sticking them inside your domain logic where they don't belong. Now, as a real world example with that container example, when you change the weight of a container, we need to log tracking, we need to send alerts to people, we need to update information on delivery jobs. There's a whole host of separate processes which happen as part of that the set weight method. Now, if we were to put all of those into the container, all we're doing is moving the big ball of mud further down into the model. So we just end up with exactly the same problem as before. So what do? oh sorry, just going back to that method. It's the same method as before, except instead of setting the weight, we're now calling set cargo weight. And it's still completely incorrect because we're not getting that alert coming out or any of the other behavior involved with the weight of a container changing. So what are we doing? Of course, we invent a new word. We're going to eventify this. So eventification was a very important part of what we were doing. The guys down here know what I'm talking about. There's a fantastic blog post by Udi Dahan, who's really the guy who created NServiceBus, which is a tool that Mark will be talking about further on tonight. Udi Dahan wrote a fantastic post which I strongly recommend reading. It's quite short, but it explains about how you can build an in-process event bus. It's a really lightweight event managing container, which you can insert into your code with a couple of lines of code. In fact, that's pretty much it. That's pretty close to what you need to decouple all of your business logic away and get some sort of a process. Without going into the extreme, the high level or the low level detail of this, what this lets us do is we can start defining our business or behavior as a series of events and event handlers. Now, this might be fairly obvious to some people, it might be new to others, but really what we're doing is we're taking advantage of dependency injection and IOC to determine we've got a particular event which occurs. What are the things that need to happen when that event occurs, and we just need to go and handle those events. So what we've got, I hope you can read this at the top. We've got a static class. So this class is completely static, and it is really that simple. What we have is we have a handler container which can tell us for a particular event what handlers need to occur on that event, and they can handle it. So what you might say, what does that actually mean? How does that actually help us? Well, what it does is it means we can raise the event, because the only thing that the set cargo weight method in the container needs to know about is the event processor. And that's a simple static class. It doesn't need to know about any of the other behaviors. It doesn't need to know about alerts, about tracking, about delivery. It just needs to know how to raise an event. So it takes out a dependency on the event processor, and the number of handlers are completely irrelevant. You don't change the number of dependencies on the container class by adding more handlers. So our set cargo weight method in the container now changes. We recalculate the gross weight, and we just raise a container gross weight updated event. We don't care about what happens at the other end of things. We're just saying we're going to raise the event. This can happen within the container class, and then we can attach whatever behavior we want to that event. And it'll happen, it is all happening in process, so that's pretty important. There's a key difference between this and something more sophisticated like an NServiceBus, which can distribute things out. So this is not stepping towards distribution of processes. This is more about distribution of business logic and making sure that we can handle things as individual units. So we can handle an event as simply as that. Our alert notification service from before is now just injected into our event handler, and the handler can just run exactly the same check as before. This has a couple of great advantages. One, we can unit test this method. We can unit test that events get raised. We can actually start to break down the whole process into a series of really small, atomic, testable methods. And so the important takeaway from all of this is this was taking a big ball of mud method. I was hoping to bring up the method showing originally what update container weight looked like in 2006, and it's horrendous. It wouldn't fit on the screen. There was pages and pages of code which said do this and check this and make sure that happens and do that and do that, and it could have all have been subverted by someone just calling set on a method, on a property, which people did. And so there were bits of the code where things would go wrong. What we're doing now is we're actually making the code express the requirements of the business. We're making it easy to do the right thing and making it easy for a new developer coming on to fall into the pit of success, for want of a better term. So the final takeaway is, with all of that in place, is that correct? It's the same code we've been looking at 3 times, and finally the answer is yes, that's correct. You can do that, and the system will deal with all of the complexity. It keeps it all in place, and it's really easy. So we've taken what was some fairly nasty, unpleasant logic, and by a couple of fairly simple, doable steps, and it really is, I have to say it strongly, it's really quite easy to do this if you do it the right way. You can actually achieve the legacy systems doing the right thing and start to get the benefits of somewhat more modern structures, which we'll go through a little bit more. So, as I said, we've broken things down. We can now unit test things, and the test becomes simple to manage. We can now write a simple unit test which says, when we set the weight, does this happen? We can actually test that events get raised, and we can test the behaviour of individual event handlers. Even the integration tests become simpler as a result. So, finally, when all that happens, we're happy and we're dancing away. So that's probably the first steps that we took as a team towards dealing with our big ball of mud, and it was quite successful by using targeted refactoring of things which we needed to change or things that we knew were broken. We were able to take some really horrible bits of the code and make them not perfect, but significantly less horrible. The question is, if we'd started from scratch, would we have done things this way? The answer is absolutely not. There are things which we would have done completely differently. But this is an approach that you can take with legacy code, which gets you a long way towards having an architecturally better system and lets you tackle that big ball of mud. So I think we're domainified, we're eventified, we're testified. Yeah. And so the question is, where should we go next? And this is where I'll hand over to Eskil, who's going to talk about how the big ball of mud hit us square in the UI. So are there any questions about any of that?
From the one that you suggested just before that, where you introduced a dependency on some alerting service, I mean, isn't it kind of the same?
Okay, so the question was, what's the difference between having the alerting service embedded in the container versus using the event processor method?
Well, I'm saying you could still inject it using dependency.
Absolutely, you could inject it into the container using dependency injection. The real answer there is, let's take the scenario where there are 4 or 5 different services that need to happen as the result of a container weight updating. If we are injecting in the container class, it means the container class suddenly has dependencies on the alerting service, the tracking service, the delivery job updating service, the widget service. Whereas if we take the in-process event bus, the only thing the delivery job class, the container class needs to know how to do is to raise an event. So it takes out one dependency on the event processor, which is a static class which is essentially available throughout the whole system. Any class can raise an event, and it's completely ignorant of any of the resulting behaviour of that event. So it really comes down to the example there. It was one dependency versus another dependency, but really what it comes down to is it's one dependency and that's it, and you don't need to inject all those other classes. Does that answer the question?
Yes, so you can have multiple subscribers to the same event.
Exactly.
That's
Yes, that's exactly right, and that allows you to do that without multiplying the dependencies ad infinitum. It leverages the power of the IOC to do that.
And the
Yeah.
event becomes explicit and visible.
Yes, yeah,
It can be very relevant information.
that's right. We have unit tests as well. There's a massive dictionary of unit tests that say when this event happens, this and this and this and this occur, and we can actually test that explicitly and say these are the things that need to happen. So, yeah, sure.
How about like a transaction, like kind of, the thing is like you set the weight there,
Yep.
and before you don't save it to the database at that
Yep.
point, right?
Yep.
What if when you notify someone, like you notify someone, you send an email,
Yep.
you do something else, event is handled,
So-
and then the
something
transaction
goes-
is dropped,
Yep.
and it doesn't get saved to the database, but the guy received an email. Like,
Something goes wrong, yeah. So the question was, how do we deal with transactions? And it's actually a really astute question. The answer is not particularly well in this. It's one of the limitations, really, of that process, which we will talk about quite a bit more in the NServiceBus side of things. But really, you are working on one transaction in the web. So it was using, in a limited way, the session per request on the web thread. So a transaction opens at the beginning of the session. Your business logic works. If something fails, it rolls the whole lot back. And when it gets to the end, it commits, hopefully. Being a big ball of mud, there were some fairly awful things that were done to the transactions and to sessions, which I could show you later on if you'd like to see. There's some pretty awkward code in there to jump around transactions. But really, yeah, we identified that as being a problem which actually led us further down the path to doing things. But it's certainly, yeah, transaction management and persistence was something which we have dealt with, but it is something we needed to tackle. Any other questions there? No. Thanks everyone. I'll hand over to Eskil to talk about UI stuff.